All right, ladies and gentlemen, this is your very first time going through a video that will have my answers to our CA1 study guide. Feel free to use this video to check your answers and to help you get started on how to attack these problems. So looking at number one, we've done number one in class for our Smart Start in all three of my classes, and so I won't spend too much time on this. This is a continuous function because it's a line, which means that we're going to report our domain and range using the example minimum, variable, and max. Our minimum domain, which would be our x values, our range, our y values. Our minimum domain value is -2. Variable is x, max is 4, closed dots less than or equal to. Range, lowest y value, -3. Variable y, highest y value, 4, closed dots. We also went through number 2 in class, domain being the number of people who can fit in Buzz Brews. Maximum is 72. That means we can go from 0 to 72, but it can only be a whole number. Why do I know that? Because we're working with people, and people cannot be decimals or fractions. Domain and range of number 3. This is a discrete function. How do I know that? Because our data is represented in dots. A useful tool to use here, especially in identifying domain and range, would be to identify an XY table. So starting with this over here, the x value is -3, the y value is -2. This dot up here, -2 is my x value, y is 0. This dot right here, careful, x is 0, y is 1. Last two, x is 2, y is -1. X is 4, y is 3. So that means our domain value are going to be all of our x values in order from least to greatest using the brackets, since that's how we represent domain and range with discrete values. -3, -2, 0, 2, and 4. Our range values need to be put in order from least to greatest. -2, -1, 0, 1, and 3. Ruben's already saving for college. Number 4. In 2016, he put $200 in a savings account. So that's his starting value. Every year, Ruben will put $150 in his account. The amount of money Ruben has in his savings account can be represented by this function, where x is the number of years after 2016. Find a reasonable domain and range. All right, so when we look at our steps in our notebooks, our very first thing that we need to do is identify our independent and dependent variable. Our x is the number of years, which means y, or f of x, is going to be the amount of money that he has in the account. So after a certain number of time, x, he's going to have a certain amount of money, y. So let's look at our domain value. If I'm working with money, I'm working with things like decimals and not whole number values, which means that this data is going to be continuous. Money can be decimals. What's my minimum x value, the number of years after 2016 when he starts saving? 0. It doesn't make sense for our time or our years to be negative. Therefore, we're going to start our time at 0. Our maximum number is going to be infinity. He could be saving forever. Less than or equal to, because our value can be 0 for time. And x is our number of years. So our domain is going to be anything that's greater than or equal to 0. Our range is our y values. Our range is the amount of money in a savings account. What is our minimum value? He started with $200 saving. And then he can save forever. And he could get an unlimited amount of money in his account. His first value for y, or the amount of money in his savings account, can equal 200. And then it's only going to grow after that because he's continuing to put $150 in there. These ones are tricky. The graph below shows the height of a ball thrown from the top of a building. Find the domain and range of the graph. First of all, this is a continuous function. It's a line, which means that we're going to use minimum, variable, and maximum. My minimum domain value, or my x value, if I'm looking at my x value, my smallest x value is going to be at this point right here. Be careful. The y value is 30, but our x value is 0. Variable for domain is x. My maximum x value is in between 4 and 5, which is 4.5. Closed dots. Following the same procedure for range, my lowest y value is right here at 4.50. So my minimum y value is 0, not 30. There's a value that's lower than 30, and that's 0. Now my highest y value is in between 100 and 90, which is 95. Closed dot values. Let's move right along into solving linear equations. My steps are to distribute and CLT on the same side. Step number 2. Move variables left and constants right. Step number 3, isolate my variable by using inverse operations. Very first step, number 1. Can I distribute? Yes, show it. Distribute means to multiply. Combining like terms is adding and subtracting. So to distribute here, 2 times 7x is 14x. 2 times negative 4 is negative 8. Equals 2. 2 is not part of the distributing. 2 times 3x is 6x. 2 times negative 1 is negative 2. I've distributed. Now I'm going to combine my like terms. 14x minus 8. These are not like terms. But I have a 2 minus 2 on the right side. And that equals 0. So this becomes 14x minus 8 equals 6x. You do not have to put the 0. Second step says I need to move my variables left and my constants right. Variables left, constants right. I'm going to move my positive 6x to be on the left side with my 14x. And I'll get 8x minus 8 equals 0. This is okay. 8x minus 8 equals 0. Now I'm going to solve for x. I need to get rid of the negative 8 by doing the inverse operation, adding 8 to both sides. Bring down my 8x. This cancels. 0 plus 8 equals 8. How do I get rid of the 8 in front of the x? Divide. X equals 8 divided by 8, which is 1. Number 2, can I distribute? Yes. Be very careful here. The negative in front of this parentheses is really just a negative 1. All right. 4 times x is 4x. 4 times positive 2 is positive 8. Equals negative 3x, not part of the distributing. Negative 1 times positive 4 is negative 4. Negative 1 times negative x is positive x. Now I'm going to combine my like terms. I can't combine 4x plus 8, those are not like terms. But I can combine a negative 3x and a positive x. Always ask yourself if there's anything that I can combine or simplify after I've distributed. Negative 3x plus x is negative 2x. Always use your calculator if you need some help. Now I'm going to move on to step 2. Move the variables left and the constants right. Variables left, constants right. Inverse of a negative 2x is a positive 2x. I'm going to add it to my like term on the left side. 4x plus 2x is 6x. Bring down my positive 8. This cancels. Bring down my negative 4. Make sure you take the signs with you. 6x plus 8 equals negative 4. Now I just isolate my variable by using inverse operations. The inverse of a positive 8 is a negative 8. Bring down my 6x. This cancels. Negative 4 minus 8 is negative 12. Check in your calculator if you ever need help. My inverse of multiplying 6 times x is dividing by 6. And be careful with your signs here. Negative 12 divided by 6 is negative 2. The total cost of renting a banquet hall is a function of the number of hours the hall is rented. The owner of the banquet hall charges $85 per hour plus a $50 cleaning fee. The following equation can be used to determine C, the total cost to rent a banquet hall for every hour, H. If you only have $325 to spend, how many full hours can you rent the banquet hall? So this 325 is something. It's one of our variables. It's either total cost or every hour. Because of the dollar sign, this is a C value. It's asking me for the number of hours I can rent the banquet hall for if I have $325. So this 325 is going to be substituted in for cost. H is hours. I'm trying to figure out how many hours I can rent the banquet hall for if I have $325. So now all I need to do is just solve for H by using inverse operations. If I'm adding 50 on the same side as the H, I need to subtract 50. Again, I want to just get my H by itself, isolate my variable. 325 minus 50, let's see what that is. $275. Get rid of the 85, divide. 275 divided by 85 is 3.23. It's asking me for full hours. Doesn't make sense for me to round this up to 4 hours because then I wouldn't have enough money. So I'm going to round down, and this is going to become 3 hours. What is the value of x in this equation? Same steps. Can I distribute? Yes. Negative 2. Distribute means multiply. 13x minus 2x minus 8 equals 8x plus 1. Can I combine any like terms? Yes, I can. I have 13x minus 2x. 11x minus 8 equals 8x plus 1. Now I move on to moving my variables. I need to move my variables over to the left and my constants over to the right. How do I move this positive 8x? Negative 8x. Negative 8x. Subtract 8x. 11x minus 8x is 3x. Bring down my negative 8. Take the sign with you. That becomes positive 1. Bring down my plus 1. 3x minus 8 equals 1. Use inverse operations to solve for x. Add 8 to both sides. Bring down my 3x. 1 plus 8 is 9. Divide both sides by 3. Inverse operation. 9 divided by 3 is 3. Number 5. Continue to distribute. For negative 5 minus x, negative 5x. Negative 5 times positive 1, negative 5. Nothing to distribute on the right side. Can I combine any like terms? Positive 4, negative 5. Be very careful with your signs and use your calculator if you need to. This becomes negative 1 minus 5x equals 2 minus 3x. Now I just continue to move my variables and my constants. How do I move my variable term on the right side? Inverse operation. Add 3 to both sides. 3x. Bring down my negative 1. Negative 5x plus 3x is negative 2x. This cancels. Bring down my positive 2. Negative 1 minus 2x equals 2. Inverse operations. Add 1 to both sides. Bring down my negative 2x. 2 plus 1 is 3. Divide by negative 2. Divide by negative 2. X equals negative 1.5. How do I know that? 3 divided by negative 2, negative 1.5. Mr. Robinson is going to Six Flags this weekend and wants to bring some friends. The total cost of going to Six Flags can be represented by this function, where $22.75 is the cost of one ticket and $7.25 is the cost for parking. Oops. It's from Mr. Denning from last year. I stole this from Ms. Fenley. Mr. Robinson can only spend $175. How many people can he take to Six Flags? So he has total cost is going to be our Y value, which means that I have $175. That's going to go in for the cost. That's going to go in for Y. Substitute in 175 for Y. 22.75x plus 7.25. Now I'm just going to use inverse operations. Minus 7.25, minus 7.25, 175, minus 7.25, 167.75 equals 22.75x. 167.75 equals 22.75x. How do I get rid of the 22.75? Divide 22.75. Divided by 22.75. 7.37. Now, we're dealing with people. X is the number of people, or the number of tickets that he's allowed to bring. He's not going to have enough money for 8 people if I round up. So therefore, I'm going to need to round down. He can bring 7 people to Six Flags with the money that he has. Who wants to go with him, right? All right, solving linear inequalities. When you divide by a negative coefficient, or you have a negative in front of the x, you must flip the sign. Solve. These are going to be solved the exact same way as equations. We just have to make sure we flip the sign if we're working with an inequality. Variables on the left, constants on the right. There are no variable terms over here on the right side, so I'm just going to solve by using inverse operations. We're not going to flip until we see if the negative is at the very end. Bring down my negative 3x, greater than or equal to 5 plus 4 is 9. Okay, now I have a negative in front of my coefficient. My negative in front of my variable, rather. I'm going to flip the sign and divide by negative 3 to get rid of the negative 3 from the x. So now it's going to be x is less than or equal to 9 divided by negative 3 is negative 3. Number 2 gets a little bit trickier. There's a negative 1 in front of this set of parentheses, so I need to distribute first. 2 minus 4, negative 1 times positive 4 is negative 4. Negative 1 times positive 3x is negative 3x. It's less than or equal to 3x minus 20. Can I combine any like terms? 2 and a negative 4. 2 minus 4 is negative 2. Minus 3x is less than or equal to 3x minus 20. Variables go on the left, constants go on the right. I have a variable term on the right side. It's a positive 3x. The inverse is a negative 3x. This becomes 2 minus 6x is less than or equal to negative 20. Negative 3x minus 3x is negative 6x. Do not be lazy and not use your calculator. Now I just solve. What's the inverse of this positive 2? A negative 2. This becomes negative 6x is less than or equal to negative 20 minus 2 is negative 22. Divide by negative 6. Negative 22 divided by negative 6. Let's turn this into a fraction. Some of your EOC and some of your CA questions have a fraction. 11 over 3. There was a negative in front of my variable, so I'm going to flip the sign. X is greater than or equal to 11 over 3. 2 more. Can I distribute? Yes. Positive 3. 7x minus 26, nothing to combine there, is greater than 3 times 3x is 9x. Do not add when you distribute. 3 times negative 2 is negative 6. We multiply when we distribute. Variables go on the left, constants go on the right. What's the inverse of a positive 9x in order to get my variable term over on the left side? Subtract. 7x minus 9x is negative 2x. Check that in your calculator. Bring down my negative 26. This cancels. Bring down my negative 6. Now I just solve. Inverse of negative 26 is positive 26. Negative 2x is greater than negative 6 plus 26. 20. Negative in front of my variable. I'm going to flip my sign and divide by negative 2. X is now less than, careful, positive 20 divided by 2 is negative 10. Last one. There's an invisible negative 1 in front of this set of parentheses. 1 minus 4, negative 1 times 4 is negative 4. Negative 1 times positive 3x is negative 3x. Is less than negative 3. Are there any like terms that I can combine? 1 minus 4 is negative 3. Minus 3x is less than negative 3. Inverse operations. Inverse of a negative 3 is a positive 3. Bring down my negative 3x. Less than negative 3 plus 3 is 0. Negative in front of my variable. I'm going to flip my sign and divide by negative 3. X is now greater than 0 divided by negative 3 is 0. And that's going to be where we stop for today.